The solid edge 3D routing environments make the creation of piping systems, tubes and wire harnesses a breeze. Here we need to create a pipe route within this assembly. 3D path tools make this a quick and simple task. We can select assembly geometry to connect to. As we draw the path, we can easily enter numerical values if necessary. The paths can be maintained parallel to our major assembly axes or to edges of other parts in the model. We can also apply dimensions to parametrically drive the paths if necessary. Finishing this path off, we'll connect it to this component. The piping route command connects to the solid edge standard parts database, which contains a full library of piping standards. We can choose the standards to work to, the pipe diameter, and the material. We also have full control over the fittings that will be placed on the path. Here we're choosing butt weld fittings, but they could also be flanged or threaded, and so on. Once we've selected the path, the fittings are placed in the appropriate places. This includes the T's, elbows, reducers, and more. The pipes are then automatically created at the exact required length. Additional fittings can be placed. For instance, we may want a flanged fitting at the end here. The standard parts dialog guides us to the correct standard and fitting sized based on the pipe material. We can also automate the creation of a pipe path. Here we simply pick the start and end. Then we can step through the different solutions. For this one, we'll set an initial port length and create this path. To further control the path, we'll add a couple of dimensions. Modifying a dimension value will adjust the path. We'll create a bent tube along this path. This gives us full control over the properties and material of the tube. Once the path is selected, the tube is created. Maybe we want to apply an end condition to the tube. We can extend the length slightly, then choose the shape we need, such as expanded, flanged, closed or reduced. We can then preview to see the results. Bend tables are also easy to create. We can choose single tubes or all tubes. This gives us the manufacturing information for the tube, which can be sent straight to a tube bending machine. Solid Edge also supports flexible tubes. These could be defined at a fixed length, or they could adjust dynamically. Documenting our tube and pipe systems in 2D is also easy. We'll choose this assembly and choose a display configuration that contains the pipe fittings and the tube paths. A front view will be a good starting point. We'll also fold off a right view. The drawing views could now easily be documented using the excellent Solid Edge drafting tools. Let's place another view to look at some more detail. Again, we'll choose a display configuration, then set an appropriate scale and place the view. This time we'll create a parts list. We'll restrict the list to only contain what we see in the drawing view. As you can see, this includes the fittings and pipes along with the cut lengths where appropriate. Switching to the harness environment, we have tools to easily create wires between components. This can be automated by importing wire lists from ECAD systems or it can be manual, as in this case. We can choose wire types from a standard database. We also have full control over the properties of the wire. This includes the ability to constantly monitor for minimum bend radius violations. The length calculations for the wire are also live. Individual wires can easily be bundled together and routed through the assembly. Selecting geometry within the assembly will create the appropriate bundle path for us. We'll repeat this process on these other wires. Once again, selecting the assembly components to control the bundle. Other ways of doing this allow us to create 3D paths on the fly and dynamically adjust them within the assembly to control the positions of the wires. As the wires are adjusted into the bundles, their individual lengths are still being monitored. Once done, the physical conductors for the harness can be created. This creates the solid model for each wire and bundle at the correct size. Of course, this then allows for interference checks and so on to be performed. Harness reports can be run directly from the assembly. Here we'll report on the connections. We can see from to information, as well as cut lengths and more. A harness can also be documented in 2D. This allows us to flatten the harness and create full-size or scaled nailboard drawings. This is a full-size drawing. Once placed, we can manipulate the harness. We can also add bends if necessary. Drawing views of the connectors on any given wire can be placed. We'll make the scale of this one larger. Then place a view of the connector attached to this wire. Placing a connector table will also label up the connector terminals for us. The table lists the pin numbers and the wires for the connector. A conductor table will create a report for the complete harness. This will include from to information as well as cut length and true length information for each wire. The report can be customized if necessary. Finally, we can also use an intelligent callout to retrieve specific information for each wire, bundle or cable in the harness. Here we want to extract the name. The solid edge 3D routing environments, making the creation of piping systems, tubes and wire harnesses a breeze.